Hello, space fans. Welcome to another Hangout on Air with Astrophysicist Katie Mack. How are you doing, Katie?
I'm good. How are you doing?
I'm exhausted. It's midnight here. We've had a really long night or long day across the world doing some global outreach for One Sky, but that's a topic for another show. Um, but for those of us watching now, we talked 2 weeks ago about black holes,
Yep.
especially or specifically Sagittarius A star,
Yep.
ours, and I'm hearing myself. I think I have my video open. I do. There we go. Always professional. Start hearing my own video feed. But so we were talking about our own Sagittarius A star, our own supermassive black hole. But there's so much more to be told about black holes. So we're having you back, and we're going to dig into a few things. But I want to let people know first how they can get a hold of us. We are on Twitter. I am Scientific Scott down there, and Katie is Astro Katie.
Astro Katie should be over here somewhere.
Right there, right by your
Yep.
PhD comic, which I'm still like nerd cred all the way. Uh, Also, you can leave us comments here on YouTube. So I have a tracker going on, well, over here for me, so I can see your comments as they're coming in. I already have a few, and then we're using the Q&A app as well on Google Plus and YouTube. So you can click that, and it'll let me timestamp your question. So if you give me a question and we're answering it live on air, I can click it, and you can actually see where and when your question is being asked or answered because it was already asked by you. So. Paul Stewart says good morning, Katie and Scott. So good morning, yes, or afternoon. It's evening, and it's evening for Paul as well. He's in New Zealand, so
It's about 5 p.m. here.
5 p.m.
I'm in Melbourne, by the way. For those of you watching who are not aware, I'm in Australia. So this is a very sort of international event happening.
International events for the
Yes.
win, always.
Yes.
So when we left last week, you were actually,
Yeah.
or 2 weeks ago, you were
2 weeks.
getting ready for your Reddit AMA. So you're
Yes.
Ask Me Anything. How did that go?
That was awesome. That was a lot of fun. So that was set up through the University of Melbourne, and I went on there, and people asked questions about dark matter, black holes, cosmology. They asked about the early universe, about the multiverse, about inflation, all sorts of stuff.
So just
Um,
all the mind stuff.
yeah, all the
Oh, yeah.
mind-blowing stuff. Yeah, and so I answered questions for an hour, and then I came back to it later in the day, and I answered some more questions, and it got a lot of attention. It was on the front page of Reddit for a little while.
I saw
I got to
that.
like number 14, I think, which was amazing.
That's awesome.
Um,
So like
yeah.
you just are like glowing nerd cred, like super hardcore. I mean, when
Yeah.
'cause we were talking when it was going on, and so I was going through it and reading some of the stuff, and then later on, I think it was on Facebook, I saw that you're on the front page of Reddit, which is awesome.
I took a screenshot.
I think okay, so I love CGP Grey, and I think that you beat out CGP Grey on stuff like that. So you gotta step up your game, Gray. Sorry, but
But anyway,
on your AMA,
yeah.
were there any topics breaching onto black holes in our topic of
Oh yeah, yeah.
conversation?
Yeah, so a bunch of people had questions about black holes. I think that black holes really capture people's imagination. A lot of times people think of black holes as these sort of evil, monstrous things that are going around eating things in the universe. And we always talk a lot about what happens if you fall into a black hole and how you get ripped apart, and that's all fun to talk about. But black holes are just everywhere in the universe, and for the most part they're pretty harmless. So it's fun to talk about like what black holes actually are astrophysically and what role they play in the galaxy and in other galaxies and just in the universe in general. But yeah, so the questions I got were things like, can black holes eat dark matter? Which they can, although it's they don't eat that much dark matter for complicated reasons having to do with dark matter, which we should talk about at some point.
Later, yes.
Another thing.
Yes.
Then people asked, somebody asked, are black holes good for anything? Like, can you use them to, I don't know, power a car or something like that?
Okay,
yeah.
To power a car.
And the answer to that is no. I mean, so there's actually been some work on ways to extract energy from black holes by exploiting sort of subtleties about if a black hole is spinning. There's like a region where you can throw stuff in and stuff comes out, and not within the event horizon. It's a little bit complicated, but there are sort of discussions about how to extract energy from black holes just by using the fact that you have like a sort of massive gravitational thing that's spinning and it distorts space-time, and you can kind of, if you have vastly superior technology, find ways to kind of exploit that. But it basically wouldn't ever be worth your while because it would take so much energy to build something that could do that that I don't think it's ever practical.
It's just not economically viable at that point.
Yeah. Well, one of the things, the answer I gave to that question, I brought up something that I used to think about when I was a kid, which is, so black holes, like any other massive object in the universe, can bend space-time. And so anything in the universe that has mass bends space-time. This is something that we know from general relativity, Einstein's theory. So you can think of space-time as sort of like a sheet, and you put something massive in, it makes a dent. I mean, this is the usual illustration, which is not a good illustration because you have to kind of bring it up a dimension to get it to work out. But anyway, you can,
and then observe from outside that other dimension as well. Yeah. So it's not a great analogy, but it bends space-time in the sense that if light is trying to move past a massive object, it'll be curved around that object because of the bending of space-time, and that's called gravitational lensing. And when I was a little kid, I used to, not a little kid, I guess, but I was a little bit older, maybe a teenager, if I was sort of driving on a back road and it was dark and I was going around a corner, I noticed that my headlights were just going straight ahead, and I couldn't see around the corner because that part was still dark, and I thought, like, wouldn't it be really convenient if I had like a little black hole, sort of suspended in front of the car on like a stick, and it could bend the light for me and make this nice, sort of gravitational lensing to bend my headlights so that I could see around that corner. And I thought that would be really useful. But if you actually like work it out, if the black hole is small enough to give you like the right level of lensing, it's going to be so small that it's going to like sort of shoot off at the speed of light, or not quite the speed of light, but almost, because if they're that little, they're probably moving quickly and it'll just leave. And you can't hold on to it anyway. But also, but then if it's a bigger black hole, then it'll destroy the car and you have bigger problems. So it's not actually practical. That's just not practical.
No, but so that was part of my answer to that question.
That's awesome.
That's what I used to think about when I was younger. Because there's no other way to bend the light from your headlights, because light is just going to travel in a straight line.
Right.
Unless I guess you could use some kind of lens, like actual physical, glass or something. But I didn't think about that. I only thought about black holes.
Right. Well, why? There's no other practical thing than black holes.
Yeah.
That's where I'm going with it. So when we're talking about, you were talking about these different sizes, and so last week we talked about supermassive, or 2 weeks ago, supermassive black holes. Now you're talking about teeny tiny ones.
Yeah.
How do they come in different sizes? Do they form differently? Between a stellar black hole and a supermassive black hole? Is it just a different diet they're on? What's going on there?
They're really different formation mechanisms. So the sort of standard black hole is the stellar black hole, or stellar mass black hole, which is a kind of black hole where basically when a star burns out all its fuel, it has nothing to hold it up anymore. So the nuclear fusion is the stuff that keeps a star puffy and gives it that pressure support. That pressure is balancing against gravity. When you run out of fuel, the star starts to collapse and goes through stages. You get a white dwarf, then you get a neutron star, and And if you're too massive to be a neutron star, you can become a black hole. So, there's a point at which, after you've burned out all your fuel as a star, you can collapse into being a black hole because there's nothing to hold that thing up as like a physical object with size.
Right.
So that's a stellar mass black hole, and I can talk a little bit more about how those are formed. The other kinds of black holes are, there's the supermassive black holes that we talked about before, and those probably you start with a stellar mass black hole, and then it accretes matter, so it just pulls in gas and dust and stars or rocks or whatever that happen to be nearby. Whatever comes close enough to it, it can eat that, and it can grow through that accretion process. Usually, you'll have an accretion disk, so you'll have a disk of matter that's all sort of swirling into the black hole, and that's how we think supermassive black holes form, through a combination of that accretion and also mergers, where smaller black holes can fall in and add to the mass of the black hole and make it supermassive. Although it's actually it's still kind of unknown exactly how supermassive black holes get so massive. So we've seen evidence for supermassive black holes of like 1 billion times the mass of the sun in the first billion years of the universe, and we don't know.
That's really soon.
Yeah, we don't know how they grew that fast. So when we sort of work out how much matter something can pull in through accretion, it's really difficult for the black hole to eat that much matter that quickly, because basically, as stuff is falling in, the stuff that's falling in has its own pressure, and it's gonna radiate, and that radiation kind of keeps more stuff from falling in so quickly. And so trying to get a lot of matter into the black hole really quickly is hard. And we don't know, it's still a mystery how those earliest supermassive black holes formed. Now there's a third category. Sorry? Yes?
Is there, how would an astrophysicist go about researching that? Is there any evidence that they can look for to help understand primordial supermassive black holes?
Yeah, so mostly we look at observations of those early black holes, and we try to improve our models of these accretion processes through things like simulations, trying to simulate different ways that accretion can happen that can allow something to grow that quickly. We also look at what the masses of the first stars might have been, because the first stars are different from the stars forming today because they're forming out of different kinds of gas. Because the very beginning, we only had hydrogen and helium, really. We didn't have a lot of other elements. And so stars that formed in the very early universe had different properties than the stars that formed today. And one of the theories is that they were very massive. So they were like 100 times the mass of the sun or more, typically, whereas these days most stars are less massive than the sun.
Right.
And so if stars in the early universe were a lot more massive, then the black holes could have got sort of a head start in growing, and so they might have had more massive seeds before they started accreting, and that would make it easier to grow faster, or to become as massive as we see as quickly as they did.
Right.
So those are some ideas that people think about, and just trying to kind of understand the physical conditions in the early universe, trying to look at the spectra of these very, very early galaxies that we see, and try and learn something about those black holes. I mean, when we look at, we can see the effects of these supermassive black holes at early times, because we see these extremely bright emission sources, and it's counterintuitive to think a black hole can be bright, because obviously one of the things that defines black holes, or the thing that defines black holes really, is that nothing comes out of them.
Right.
But they appear really bright because a lot of things are going into them, and this accretion disk lights up because it's just so much matter coming in so quickly and crashing into itself, and so you get this extremely bright X-ray source and gamma rays and things like that. You get jets coming out from magnetic fields getting all twisted up and accelerating charged particles. So you end up in the situation where a lot of times a black hole that's accreting can be like the brightest thing, the brightest sort of consistent source in the universe.
It just sounds like the universe is going through things and asking, will it blend? And just, and everything's coming together every which way.
Yeah. So we have these massive, supermassive blenders out there, these supermassive black holes, and so when those sources are really bright, those are called quasars, and we can see those quasars in the first billion years of the universe by looking far enough away. We can see the earliest quasars, and so we know that they're out there, and there are quasars nearby as well. Our black hole is not accreting that much. We talked about this last week. Our black hole in our galaxy, supermassive black hole in our galaxy called Sagittarius A star, only eating a little bit, so it's not a quasar. But if you have things set up so that the black hole is accreting a lot, then you do get those bright sources. So we know they're there. We're not really sure how to make them. There's a third category of black holes that's entirely theoretical at the moment, which is primordial black holes. And this is an idea that Stephen Hawking came up with, along with a few other people in the 70s. And the idea behind primordial black holes is that in the very early universe, before the first stars, before even the cosmic microwave background and stuff, just very, very early times, there might have been little fluctuations in density throughout the universe. And some of these fluctuations might have been so dense because of whatever processes were going on in the early universe, that they could have made little tiny black holes sort of immediately.
Okay.
And if that happened, then you could have little itty bitty black holes that are, less massive than the sun, that just formed out of that primordial soup through various. There are a lot of different theories about how you can make primordial black holes. All of them are a little bit speculative here and there, and there's no evidence that they actually exist. But you could have these little fluctuations and make these little black holes, and some of those would be like the mass of an asteroid, like 10 to the 15 grams, something like that. But they'd be tiny. They'd be less than the size of a nucleus.
Oh wow!
So yeah, because black holes are very, very compact, and so these things, if they were to be formed in the early universe, then the main way we'd know about them is that they would evaporate. So I don't know if you've heard of Hawking evaporation.
I have.
Yeah.
Which that might even be a topic for another show too.
That could be an entirely different topic. Yeah.
Yeah. And real quick, I do want to get to some of the questions that are coming, because actually getting quite a lot.
Okay.
And I guess the great start to these is, Katie. And not you, Katie, but Katie Stocco from the UK asked, how did black holes get their names? Is there a real reason for it? Or is it kind of, what's the etymology of black hole?
So my understanding, and I could be wrong about this, but I think I heard some people talking about this just recently, is that John Wheeler was giving a talk about black holes, and somebody... And they didn't have that name yet, and somebody in the audience suggested the name black holes, and it stuck. And it's not clear who came up with the idea, but I think John Wheeler was the first one to use that term in the scientific literature.
That sounds like just profound citizen science right there.
Yeah, definitely. I think the original idea of black holes, I think they were originally called dark stars, but they're now called black holes, and there's an entirely different weird physics idea that people talk about sometimes that's called dark stars now.
Oh, so that term is now designated something else.
Yeah.
Which is, I just feel like Alton Brown, that's just another episode altogether. Where he eats for space. Another one I want to ask you. This is from from Physics Girl, the Physics Girl on Twitter, asks. Are there any binary systems with a star and black hole orbiting one another?
Yeah. So this is
last time, but let's go a little bit deeper in what we mean by that.
Yeah. So this is how we see most of the black holes we see in the galaxy. So a lot of times you can have a situation where you have a binary system where there are two stars, and one of them goes supernova and becomes a black hole, and the other one is still bound to it. And then the black hole, the newly formed black hole, can start eating the other star. So it starts to kind of pull in the atmosphere of the other star and kind of feeds off of it and rips it apart.
You mean kind of like this? We were talking about this before we went on.
Yeah, exactly. Yeah, so you can get this accretion disk around the black hole where it's the stuff that it's accreting is the atmosphere of its companion star, which is so, so mean. But anyway,
Yeah, it's like, no,
yeah,
no, you're eating
yeah,
me.
yeah. So it can like totally eat its companion star, and that's called an X-ray binary, and it's called an X-ray binary because that accretion disk is so hot that it's putting off X-ray radiation, so very very intense radiation, very high energy radiation from all that matter that's falling in and sort of colliding and getting heated up as it's falling into the black hole. So yeah, so we see those all over in the universe, and all throughout our galaxy we see these X-ray sources, and most of them are something like a black hole eating its neighbor star. Sometimes neutron stars can do that too. So you can have these X-ray binaries where it's a neutron star instead of a black hole. It's eating the companion star. But if you look at a map of the X-ray emission in our galaxy, I think I sent you one of those earlier as well.
You did. Let me see here.
Okay.
Let me pull it up. Zoom and
Okay.
Enhance on the internet. Let's see.
Yeah.
Screen share that. There we go.
So in these, let's see. Okay, yeah. So in this picture, you can see all those little circles, those little dots, are X-ray sources, and those are mostly compact objects, which are either neutron stars or black holes eating their neighbor stars, which is just kind of sad. But anyway, so so that's how we see a lot of the black holes that we see in the universe. Because if they're not accreting something, then they're pretty much invisible.
Right.
You can maybe pick them up with gravitational lensing if you're very, very careful, but for the most part, they wouldn't be very visible unless they're eating. So we see them everywhere, but they're kind of just part of the ecosystem. It's not like they don't go around like attacking neighbor systems or something. Most black holes, if they might eat what's nearby, what's really close to them, but they're not gonna like swallow up the whole universe. If you're far enough away from a black hole, it's just like being far from a star. You feel the gravity, but you're not like ripped apart by it unless you get too close.
Well, Paul Stewart actually asked a question along those lines here. And said, is it possible for a black hole to wander through the solar system and devour the Earth, like in those doomsday movies?
If there were a black hole that happened to be on a collision course, then that would be bad. But
we'd have a bad day.
That's kind of it's pretty unlikely because there's a lot of space between the stars. Our nearest star aside from the sun is 4 light years away. There's a lot of empty space, and there are things like rogue planets out there that occasionally fly around in the galaxy. Things where you have like an interaction of many objects, and one of them gets ejected because of the sort of gravitational interactions. That can happen, and black holes are things that can get a kick, in some direction through gravitational interactions. So, in principle, sure, it's possible that a black hole or a rogue planet or something could wander through, but we haven't seen any evidence for anything like that happening, and it's just really, really unlikely to get any kind of direct hit or near encounter from another object.
Near encounter of the used to be known black star kind.
Yeah.
That's. We only have a couple minutes left, so I'm looking through some of the questions here that are up on YouTube. See, Jenny Powers commented, like Vegas, what happens in a black hole stays in a black hole. Is that necessarily true, though? Is that true?
So this is a big controversy in physics right now, whether or not black holes destroy information. And by that I mean if you threw a toaster into a black hole, it would increase its mass by the mass of that toaster, but would you ever find out that it was a toaster that went in? Is that information that the toaster was the thing that went in, is that lost or not? This is a big controversy. Stephen Hawking is one of the people who talks about this a lot. Leonard Susskind, Polchinski, a whole bunch of these people are sort of debating this constantly. And it's unclear at the moment One possibility is that there's the information, the sort of record of what's gone into the black hole gets like encoded on the event horizon in some way through something called holography. This would be an entirely different show
Yeah.
to go through this, but
I
you know,
love this.
it's something that's
You
unclear.
guys are just giving us more show ideas. We're just gonna keep
Yeah,
going forever.
yeah.
And actually, I'm seeing a lot of comments here too, which will have to be follow-up episodes. Something let's see here about infinite negative gravity.
Okay.
Okay, we'll have to look into that at another time. Let's see. Yeah, there's a lot of great comments, and especially since this was really last minute creating because I've been so busy this week. You guys are great for your comments, and we will definitely follow up and create completely different shows on your topic.
Yes.
But we have run out of time really quickly.
It goes so fast.
It does.
Half an hour is like so quick on this show. I don't know how.
But it's just
Time flies
because
when you're talking about black holes.
it's true, or it doesn't.
Not when you're close to them, because then
Yeah.
you get time dilation and it gets a lot slower.
Yeah, and that's like when you're trying to do all the calculations involving the black hole, and just like it's going on forever. Well, Katie, again, thank you so much for joining us
You're
here
welcome.
at Space Fan News. Where can people find more about you?
Well, I'm on Twitter and I tweet a lot. You can find me at AstroKatie. I'm also on Google Plus at Katie Mack, and I am on Facebook at facebook.com/AstroKatie. So you can look for me at any of those places. I have a webpage, astrokatie.com. So feel free to check that out.
Astro Katie, all the things.
Yeah. And if you go onto either the Google Plus page or my Facebook page or whatever, you can find the link to that Reddit AMA that I did, and also to a summary article that sort of takes an excerpt from the AMA if you just want to read a little bit.
I'll try to post those actually in the comments as well too, so people have access to them. Thank you all viewers that we've been going on here. We've actually had a pretty good turnout for this, so thank you all for watching and your comments and your tweets and everything else. If you like this and you want to see more, please subscribe, and we will try to get you even more awesome things from Katie Mack. So thank you all again, and keep looking up.
See you next time.